Hello everyone, welcome back to my channel. Today I'm gonna talk about the heap sort. Before talk about the heap sort, let's talk about what is the heap. What is a binary heap? First of all, it has a nature. The parent node will be always larger than the child node. Okay, so for each node, I have a pair. I want to illustrate the two representation of the heap. The one representation is the binary tree. The other representation is an array. So let's take this and put it here. So on the bottom, this is an array. Okay, how this array can also represent a heap? It is by the index. Let's assume this index is begin with 1. Alright. What if I want to find these numbers, parent and left child and right child? So this card is number 1, 2, 3, 4, 5. So its parent child is 5 divided by 2, which is 2. So you have 0, you have 1, 2. So this one, you see, this one is the parent of this one. And for its left child, it will be 1, 2, 3, 4, 5. 5 multiplied by 2. So you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, which is they're empty. So the 8 do not have left child. Okay, let's try a different example. So this is a bracket 10 here. It is at 1, 2, 3, location 3, and its parent will be 3 divided by 2 is 1, so which is 1, J. Alright, its left child will be 3 multiplied by 2, which is 6, so you have 1, 2, 3, 4, 5, 6. So this is the child node. What's the right child node? It is 2. It is 3 multiplied by 2 plus 1. So it's 7. 1, 2, 3, 4, 5, 6, 7. So it's 4. Okay. Let's try another example. 7. So 7 at a location 4. 4 divided by 2 is 2. So 1, 2. Its parent child is the red 10. Its left child is 4 multiplied by 2 is 8. 1, 2, 3, 4, 5, 6, 7, 8. It's a red 3. 7's right child is 4 multiplied by 2 plus 1, which is 9. 1, 2, 3, 4, 5, 6, 7, 8, 9, which is 8. Okay, now we understand what is a heap, and we know there are two representations of the heap. Now I want to talk about the heap file. Specifically, I want to talk about the max heap file. What is max heap file? Max heap file is to correct the tree if it violates the heap property. For example, if I swap these two, then you have a parent node which is smaller than the child node. This is the example of a violation of heap. Max heap file operation will correct this kind of violation. So what it will do is first you have to give the index number of the current card I want to check if it's valid. So in here the case is 1, 2, 3. So in the index 2, we first compare it with the left child, and we record the maximum, the largest index, so which is still 2, and then we compare it with the right node, which is 5, right? 2, 3, 4, 5, which is 5, and then you compare and then record the largest one, you swap it, and then you have this structure, and then you do a recursion, right? You have to do a recursion to check the largest index if it has a left child and right child. If you have left child and right child, you do a swap again. Why we need to do recursion call for the swap for the heap file? Because when sometimes we have multiple violations, okay, this is an example of multiple violation of the heap. So the heap file, you have to call heap file itself. So you have to recursively doing heap file to correct all the cases. For example, in here, you perform heap file operation. You compare this 3 with 8, 3 with 2, and you find the largest one is this one, and you swap. Okay, and then you recall the largest index. You do another heap file. So you recursively call heap file function. So you find this one largest. Okay, and then you swap, and then you find this one do not have left child and right child. Then that's finished. In this case, you will need the recursion because you have to swap twice. Okay, so we understand the heap file operation, and it is a recursive operation. Next, I will tell you how to build a heap from a random array. We have this, right? We shuffle to whatever order you have. Okay, we first have an array, but I just use the tree representation for better visualization. But you can think about it as an array. Okay, now I have this. How to build the heap? So to build a heap, we first need to find the size of array. In this case, we use the one index method. So start from 1. We have 1, 2, 3, 4, 5, 6, 7, 8, 9. So the size is 9. And then we use 9 divided by 2. 9 divided by 2 is 4. So we start at index 4. 1, 2, 3, 4. Start with this one. We do the heap file operation. Heap file operation tells me to compare it with the left child, and this one is largest index. I recall this location, and then we compare this one with this one. Then this one become the largest. So I record this location, and we perform a swap. Okay, and then because this is the largest location, I do a recursive call, and I found that there's empty. So this heap file operation is finished. And then we go back one index. So we have 4, then we go to 3, we check this one, we do the heap file operation, we compare this one, we find the largest one location, and then we compare this one, this is still largest one, so I swap with it. Okay, and in this location, I do another recursive call of heap file, and I got 0. I got there's nothing there, so I do not change. And then I go back to this one. I do a recursive, I do a heap file call. So I have compared this one to this one. This one is the largest location, and this one to this one. This one also largest location. So I swap this one with this one. Okay, then and I got this one. I perform another heap file. So this one compare this one largest. This one compare this one largest. Okay, it is itself. So the heap file operation finished. Okay, now we finished the second index, and then we go to the first index. We compare these two, and this is the largest location, and this one is this one compared with this one also the largest location. So I swap this one with this one, and then I check this one, do another recursive call for the heap file operation. I compare this one with this one. This is the largest. This one is not the largest, so I need to swap. Okay, and then I compare this one, and it doesn't have child. This one doesn't have child. So this finished. Then we got a heap based on the random array. We can check if it's a real heap. So the parents always larger. Okay, parents larger. Yeah, so it is a heap. So that's how to build a max heap. Okay, now we know how to build a heap from a random sequence. So right now, I'm gonna talk about the heap sort. So what is heap sort? Let me shuffle those cards. Okay, so the heap sort then tell me if you're given a random card, like a random array, you want to first build a heap and then perform the max heapify operations. Let me illustrate it. Okay, So you first build have a sequence, right? You can think it's an array, but I just arrange it as a tree structure. That's for better understanding the concept. Okay. Now we have this array. We start 1 to 9. And then we do the heap operation as we previously do. So we found the half of the index. So we have 9 divided by 2, which is 4. 1, 2, 3, 4. So start from here. I compare, find the largest position, swap, alright. And this is the largest position, check it's empty. Okay, now we go to the next one. So which one is the largest one? 8, and swap, and then compare is have empty. So that's finished. And then do this one. We compare, we found this is the largest one, and then we swap, and then we do another recursion call for here. Compare, this is the largest one, we swap, and then check this one, empty. Okay, that's finished. And then we do this one. So we compare, this one is the largest one, swap, and do another heap file. This one largest one, swap, do another heap file. This one largest one, swap. Okay, now we get a heap. But this array is not sorted, because when you check the order of the array, you have J, 10, 8, 4, 10. Okay, so this is not sorted for here. So after we build the heap, then we need to loop down from the n. So from this position down to 2. So to this position. Okay, we want to exchange the root with this number. So we first exchange the root with this number. Okay, and then I have so we exclude this one. So the heap size will be -1. So this one is excluded. And then we perform the heap file for this one. Okay. So for the heap file operation, we perform a comparison. We found this one largest one, right? Swap, and compare the location. And I found this one largest one, and compare it's empty. Okay, so now it's good. Okay, and then I check which one, because the n will be -1. So I check the eighth one, swap with the root. Okay. And then I perform heap file. After you swap with the root, you also excluded this 2 1. So right now the heap size will be 1 2 3 4 5 6 7. Okay, so right now it's 7, and then we do heap file here, and I found this one largest one, swap, and then check this one. I found this one largest one, and check this one. This one's empty. Oh, now I got another 10 here, right? And then we did 8, and then we do 7. Okay, for 7 I swap again, right? And I do a heap file operation, and it's this one. Okay, so after swap I decrease the heap size, so this one is also excluded. Okay, so that's empty for this location, and then do heap file. Okay, I swap, right? And check the largest one. This one's empty. Okay, so no swapping here. Okay, then I go down by 1 index, so I swap with this one, and the size decrease. Okay, so this one gone. We do a heap file. We found this one largest one, and I swap, and this one has these 2 gone. They have 0. Okay, then we do this one. I swap, and then I do heap file. We found this one largest one here, and then check the largest location with this one. Oh, I do not check because this one is already excluded, because this one is the size will be -1, right? So this one is empty, so I just swap with this one. Okay, and it's empty. Okay, then I check this one, swap. Okay, exclude this one, then I have this one, and I do a heap file operation, and this is the largest one, and it has empty. Okay, and then I do this one, swap. This one is excluded, and then do the heap file. So you have these 2, and that's correct order. Okay, and then you swap with this one, and this one is included, and you left the node. Okay, so after this operation, you got this structure, and let's rearrange this one to an array. So you collect them in order. Okay, so we have 1, 2, 3, 4, 7, 8, 10, 10, J. Okay, so this is a sorted array. So that's the concept of heap sort. The major component is the heap file. So first you build a heap with the heap file operation, and then you loop down from the child to the node, and then you perform another heap file operation for the root. When you perform this kind of algorithm, eventually it will get in the largest from the root, right? Because you swap this one with the last one, you always get the largest root swapped with the one you at the end. So you will have a sorted array. Okay, now the concept part is finished. Let's do the coding part.
Because this video is too long, so the coding part will be the next video. Thank you.